We have discussed about the giant molecular structures, right? Covalent structures, sorry, giant covalent structures, in which we have discussed about the diamond. Then we discussed silicon, graphite, right? These are
Hmm.
giant
Yeah.
structures, and these all are covalent structures. And we also discussed that when we talk about the simple molecular structures like ice, phosphorus, sulfur, their melting points are quite low. But when we talk about the giant structures like silicon oxide and diamond, they have high melting points. And what is the reason that their melting points are very high? The silicon dioxide and diamond.
Because it's
Hmm.
a metal,
Yeah,
and
and because hmm,
it has strong covalent bonds.
yeah, strong covalent bonds, and they are giant structures. They have many atoms. Okay, they are giant structures. Okay,
Yeah.
uh, they are not molecular solids with weak lattice. Their lattice is strong. Okay, in molecular solids, the above, the ice, phosphorus, sulfur, these are molecular solids, and their lattice is weak. Lattice means their bonding is weak. But when we talk about
Hmm.
the lattice means arrangement. You know the arrangement. This arrangement. The
Yeah.
this is weak. But in silicon dioxide and carbon, they have strong lattice because they are made up of uh, giant structure. They have many atoms. That is why their melting points and boiling points are very high. If we talk about the diamond,
Hmm.
they have mentioned it is the very hard. In fact, we say that this is the hardest known compound on the earth. Okay, so why we say that
Hmm.
diamond is the hardest one? We say this on the basis of its bonding. You see, in diamond, every carbon, all the carbon, no matter how many carbons are there, every carbon is bonded to further four carbon atoms. Okay, so every carbon's valency is completed in diamond. No carbon atom is vacant in this. Okay, that is why we say that
Hmm.
diamond is the hardest one because in this carbon, in this all the carbons are full of atoms, right? All of them have full valency. They have forced, every carbon atom is making four strong covalent bonds. That's why we say that
Hmm.
diamond is the hardest non-natural substance. For the same reason, we say that it has very high melting point. You see, 3550 degrees Celsius. And
Hmm.
one more property we have discussed, that it cannot conduct electricity. My question to you is why it can't conduct electricity?
Um, Maybe because like of the like when it has carbon. No.
It
Maybe
has.
because of like the strong because yeah, it's free of electrons. Yeah, because of free charge and like free electrons. So to carry the charge.
So, what you are trying to say? Are there free electrons in the diamond or not?
Yes.
They are saying it does
Yeah.
not conduct electricity.
Yeah. The
Right?
diamond has free electrons.
No, if it has free electrons, then it has to conduct electricity. They are saying it does not conduct electricity.
Yeah. There's no free. Oh, sorry. Sorry. There's no free electrons.
Think about it.
Yeah.
Yes,
There's no free
there is no free
electrons.
electron. You see, every carbon atom's valency is fulfilled. So how can there be free electrons, right?
Hmm.
Every carbon atom is valency is full. That's why there are no free electrons. You will see free electrons only when there is vacancy. Vacancy means when carbon has a valency of 4, right? If
Hmm.
carbon is making 4 bonds, it means it has fulfilled all the vacancies. It has
Hmm.
fulfilled all its vacant spaces. But if in any case carbon makes 3 bond, okay, but its valency is 4, then we can say it has valency, it has vacancy of 1 electron,
Hmm.
right? That
Yeah.
it has to make 4 bonds, but it has only make 3 bonds. In that case you can say that it has vacancy of 1 electron. Otherwise, if you see this in this in the diamond, we say all the carbon atoms make 4 further bonds, okay, with other carbon
Hmm.
atoms. That's why their vacancy is full. There is no vacancy. Their valence shell is full. They have complete octet. That's why we say that diamond does not conduct electricity. because there
Mm-hmm.
are no free ions. But when we talk about the graphene, you see in graphene we what we have discussed, that one carbon atom is bonded to three carbon atoms. Okay,
Yes.
one carbon atom is bonded to three carbon atoms. So there is one vacancy in each carbon atom. Okay, there is one, you can say one electron present on each carbon atom in the graphene, right?
Mm-hmm.
That's why we
Yeah.
say that. That's why we say that the every carbon atom, these points are representing the electrons. Okay, there are
Mm-hmm.
free electrons on each carbon atom. Because why? If someone asks you why, you will say that every carbon atom is making three bonds. It has
Mm-hmm.
to make four bonds, but in graphene, it is making three bonds only. So every carbon atom has one vacancy available. Okay, it means one electron is free in this. So if you see all the carbon atoms, it means there will be pool of free electrons, right? There is a pool of free electrons. That's why they can conduct electricity. Are you getting
Mm-hmm.
this?
Yeah.
Okay. They have mentioned the properties. Can you read this and tell me what is the difference between the properties of diamond and graphite?
Okay. Uh, Graphite uses these properties, unlike diamond, it is soft and slippery. That is because the sheets can slide over each other easily. Unlike diamonds, it is a good conductor of electricity. That is because each carbon atom has four outer shells, but forms only three bonds. The fourth electron is free to move through the graphite, forming an electric current.
Yes. So can you explain me this in your own words?
Yes. So basically diamond is like hard and not slippery, but
Hmm.
in graphite it's like it has a soft slipper because of like the space it's given, you know. It isn't like the bonds aren't as strong in
Yes.
graphite. Yeah. And that's why it says also it's a good conductor of electricity because because of the carbon like atom, it has like four outer shell but forms like only three bonds with it, so like the fourth electron is free to move, so that's why it conducts electricity because it's free electrons.
Okay. Yes. Now they have mentioned some of the uses of the diamond. You see, diamond.
Okay, can I just
Mhm.
have 2 3 minutes? I'll be back.
Okay.
Thank you.
Okay. Now we have to discuss some of the uses of these. First thing is about diamond. You know, diamond is very hard, as we have discussed that this is
Hmm.
the naturally known the hardest substance. So we can
Yeah.
use it in tools for drilling and cutting, right? You can, in the drills and cut if you want to uh, do this. Otherwise, if you are going to cut diamond, you know how it will be cut down? It will cut down in this is in such a structure, in a crystalline form. Why diamond does not cut in powder form?
mm, like why does what not go?
Why diamond does not cut into powder form? Powder. Like if you break
Maybe
it.
because of like its hard covalent bonds
Yes, because of these,
structure.
because it has a lattice, it has a
Yeah.
proper lattice. Crystal.
Yes.
It has a crystalline structure, crystal-like structure. That's why if you break it, you will get small crystals. You will not get powder. Okay. But if you break graphite, you will get powder in this. Because you see
Mhm,
over here there are weak bondings. These are weak lattice. So this
mhm.
is one of the most important properties of the diamond. Okay. As well as in silicon dioxide. These are present in the form of quartz. And the have you ever seen the sand under sunlight? It shines.
Yes, sometimes.
Yeah, it shines because of this the quartz. It We get the sand from the quartz, and it has a
Hmm.
proper lattice, and it shines in the sunlight. It has proper crystalline structure.
Hmm.
That's why. Okay. Uses are diamond is used in tools for drilling and cutting. It doesn't mean that you will make a drill of diamond. We always use diamond for like jewelry or for these things. But In tools for drilling and cutting, if you want to cut something, you can use diamond to cut that thing because diamond is very hard.
Mm-hmm.
Then graphite, it is used as, it is a lubricant for the car engines and locks. You know about this? This is a lubricant
Mm-hmm.
in the engines. If you ask your dad, he maybe he will tell you about this. That in car engines, the lubricant which we use in car engines, that is made up of graphite. You can check on the lubricant bottle if you have in your home, in your car.
Mm-hmm.
Like there are in Pakistan, there are companies like Zik or some other companies. So in that on that bottle, you can check that the in the substances it will be written there, graphite. And lubricant is made from the graphite. Do you know what is the purpose of lubricant?
Um, no.
If engine, our car engine work when we drive the car. So to avoid any jam in the engine, we use lubricants. Lubricants provide is you can say it helps to move it freely, the engine, right? In
Mm-hmm.
engine there are pistons, there are four pistons. Those pistons are pressed. So
Mm-hmm.
otherwise your engine will be jammed. That's why we use lubricants. Like our mothers use oils in machines. Like I don't know about there, but in Pakistan I have seen that when a machine is not working, the people used to add oil in that machine, some drops of
Mm-hmm.
oil in the engine, because that oil gives the lubrication. Lubrication means it helps to make that machine move freely. So that's why we add graphite. We use it as a lubricant so that engines can work properly. Otherwise, engine can jam.
Mm-hmm.
If you will not use car for 100 days, maybe you can say 100 days, and you have not checked your car. After 100 days, if you will start, your car will not start. Why it will not start? The engine is jammed, right? Because the engine is
Yes.
jammed. So that's why on frequent basis we use to apply lubricants in the engines of the car or any automobile, heavy bike or trucks or everything. That's why the people used to go to the workshops every month to check
Mm-hmm.
whether is there any issue in their car or everything is smooth or not. In locks
Mm-hmm.
as well, if you go in a place that is very old and you want to unlock the door, that will not be unlocked easily. You will need to apply oil there because locks are jammed. So
Mm-hmm.
lubrication means to make them freely, to you can say to make friction free, to make the machine friction free
Mm-hmm.
so that it can work properly. Okay. And this is soft and slippery, that's why we use it as a lubricant because this is soft. Second thing is, it can conduct electricity. So we can use it as electrodes. You know about electrodes? Have you
Uh,
studied electrolysis? Any idea about electrolysis?
no.
Okay, simply we can say in batteries. In batteries there are two strips, red and blue. Those
Mm-hmm.
help to conduct electricity. So in that we use graphite. Okay, those two strips are made up of graphite. Those are known as
Mm-hmm.
electrodes. Then silicon dioxide. This is we use it in sandpaper. You know about sandpapers?
Yeah.
Okay. So this is hard. It can scratch other substances, right? And it has very
Mm-hmm.
high melting point. So we use it in bricks for lining furnaces. It is very common use, right? You know this. That sand we use in bricks for lining furnaces. We like we make the walls by combining bricks. So how you combine bricks? By applying sand, right?
Yes.
By making its different composition, by making the different composition of the sand. Okay,
Mm-hmm.
so this was about the uses of the giant structures. Now we are going to study about the bonding in the metal. This is your homework. Okay, do this tomorrow and send me this one. You
Which
can
one?
take
Like this?
these questions. These are very easy.
Okay, okay, shush.
You can take screenshot
Yeah.
and
Yeah, I took. Okay, okay.
okay, okay. The bonding in the metal. What do you know about the bonding in metals? Like, what is your idea about this?
Bonding in the matter.
Hmm. What are metals?
Metals are basically like a lattice that's like it has like a good bonding.
What is a metal? Simply, if someone asks you what is a metal,
Metal is basically like metal is basically like a solid, but like it's shiny and like it's like it's good at moving heat and electricity.
yeah, metals. You can say metals are type of elements.
Conductive.
Like they
Yeah.
are, yeah, we have different type of elements in the periodic table. Among them, some are metals, some are non-metals, and some are metalloids. Okay, so we can simply
Hmm.
say metals are elements. Okay, and they are
Hmm.
special type of elements which can conduct electricity and heat. And why they can conduct electricity and heat? Because of free
Because of
electrons.
its free electrons.
Yeah,
Yeah.
because of the free electrons they have. And so if we talk about the metallic bonding, the bonding in the metals, okay, remember that the bonding in the metals is known as metallic bonding. What is this? This is known as,
Metallic bonding.
yes, metallic bonding. Okay. Simply we say this is a connection. This will be a chemical connection between two metal ions, right? You will have,
Yeah.
if you see this, there is, yeah, this one.
Hmm. Yeah.
How metals are bonded together? Firstly, you see there is one copper, this one. This one is copper, right?
Hmm.
Yeah, this one is copper. Then there is another copper, right? Then there is another copper. Also, we have
Hmm.
discussed that whenever you have metal, if you know that sodium, we have discussed sodium, potassium, all the group 1 elements. We know that in the group 1, the all the elements they have, what if we talk about the sodium, it belongs to group number 1. It means it has one electron in its valence shell, right? It has,
Hmm. Yeah.
I am just making the valence shell, okay? The one electron in the valence shell, okay? So similarly, every metal, they will have valence electrons in their valence, they will have electrons in their valence shell, right? Are you agree with
Yeah.
this? Do you agree
Yeah.
with it?
Yeah.
Okay. So if we talk about copper, it is copper 2 plus. It means copper, if you take copper, its valence shell will have two electrons, right? Its valence shell will have two electrons. You see, this is 2
Two
plus,
electrons.
right? It means it can lose two electrons. So remember this thing, this is very important concept, that if you bring another copper in front of this copper, you know, this copper,
Hmm.
if you bring this copper
Yeah.
in front of this, what will happen? The electrons of this copper will come out, and electrons of this copper will also come out. That's why they will available in this free space. I am saying
Hmm.
that if you have two copper, let's say this is one copper, okay, is one copper,
Yeah.
making this. Now you have taken another copper in front of it, okay. So
Yeah.
if you bring them close, they will be close enough that they will lose their electrons in this area, in this region, okay, in this free space. That's why
Hmm.
we say them, they have free electrons. Are you getting this? That their valence electrons will be present in this area, in this region, where they are close enough. Like, if you have two coins and your friend approaches you, he has also two coins, okay, and you both are coming closer to each other, what you will do, you will place your two coins in front. Like, let's say there is a table. On this side you are standing with two coins, and on this side your friend is standing, okay. So you will drop your two coins here, and your friend will also drop his two coins here, okay, in this region. So this happens with the metals as well, okay. Like when they approach each other, they they don't hold their valence electrons. Remember what I'm saying? They don't
Hmm.
hold their valence electrons. They release their valence electron in this region, okay, nearby them. When two metals are approaching, they will release their electrons in between the in this region, okay. Read this. They have mentioned over here, in metals,
Hmm.
the atoms are packed tightly, okay, they are close enough, they are close enough in a regular lattice, The tight packing allows outer electron to separate from their atom. What they're saying? Outer electron of this copper, outer electron,
Mhm.
these two, these will be separated from their atom. And where they will go? In between this region. Just like I gave you the example, like if you are standing here and your friend is standing here, and in between you both, there is a table, right? So you,
Mhm.
when you
Yeah.
both will be close enough, you will release two coins on this table and your friend will place two coins on the table. So this is what they're saying, that when metals approaches each other, they are very much closer to each other. Okay.
Mhm. Yeah.
So when they are close to each other, they lose their outer electron. Okay, they will lose their outer electron.
Mhm.
The tight packing allow outer electron to separate from their atoms. The result is a lattice of positive ions. Now you see what is this? This is a lattice of positive ions, 2 plus 2 plus 2 plus. These are all coppers, as well as there is C of electrons. These dots are what? Free electrons. Are you getting this?
Yeah.
Okay. So can you tell me now, this type of bonding is very much different from the covalent and ionic bonding. That's why
Because
I'm,
of
hmm,
yeah, like the outer electrons,
yeah,
that's why.
they will lose, they will leave their atoms. Okay. If
Mhm.
there are two copper atoms, and why they lose? Because they are close enough. They're very much close. There is tight packing. Due to this tight packing, the outer electrons are separated from their atoms. Clear?
Mhm. Yeah, yeah.
And this is a pool in which there, you can see that this is a lattice of positive ions, these copper, copper, copper 2 plus, copper 2 plus, and there is a sea of delocalized electron. Now what is meant by delocalized? Delocalized means they are not localized at one position, they can be moved.
Mhm.
Rohan, I have to offer namaz now. It's
Okay,
the
sure,
maghrib.
sure. Yeah,
Yeah,
sure, sure.
you can stay in this meeting or you can leave it.
Yeah,
It is
I'll
going to end
stay.
in 5 minutes. It is going to end in 5 minutes. You
Okay,
can
then
leave
I'll
this.
leave.
Yeah, I will share the new link. Okay.
Okay, sure.